Hello, we're back talking about Pythagorean Theorem applications, and I just wanted to do a quick fun application with a circle. And in particular, a circle that is, described, this is very squeaky. A circle that is described in the Cartesian coordinate system. Let's see if I can find another blue. Okay, so what do we know about circles? We know they have a radius, right? Okay, so here's a little radius. And if I'm considering the Cartesian coordinate system and maybe some way to create this circle using points, then I'll go ahead and stick a point right here. Wherever the radius touches the outside of the circle, we'll just give that a point x, y. Okay? So we've got x, y's all around this thing to describe that thing. Now, I also want to know where the center of my circle is. So I'm going to call that this point hk. So we get to make up the h and we get to make up the k. It's just a location that describes something relative to the x-axis and something relative to the y-axis that sort of sticks the center of our circle somewhere. So using Pythagorean's theorem, here's the fun and interesting part. I can just make a little baby triangle in here. I can just make one up right here with the radius. There we go. Here's the baby right triangle that I just decided to stick in there. Notice that I can relate this xy point to the x-axis and to the y-axis. Okay. Oh, look, I called that thing down there y, and you're probably screaming at the video for the last 2 minutes that this is k. All right. So using Pythagorean's theorem, I can say, all right, this little distance here is x minus h, and this little distance up here is y minus k. So when I stick that into the theorem, I can say, oh, this distance, x minus h, quantity squared, plus this little piece of a distance, y minus k, quantity squared, must be equal to r squared. And there, we've got what we call an equation of the circle. Equation of the circle. Now, if you want to use it to have y, let's say, on one side of the equation and x on the other side of the equation, then let's start by getting this big chunk, x minus h quantity squared, over to that side. So just subtract it from both sides. That would give us y minus k quantity squared equal to r squared minus the quantity x minus h squared, like so. Just subtracted this from both sides. I could take a square root to get rid of that little square. Square root of both sides gives me y minus k equals plus and minus the root of r squared minus quantity x minus h squared. Whew, very squeaky. And then I can add the k to both sides of the equation to get y in terms of everything else on the other side. Y equals k plus or minus square root of r squared minus the quantity x minus h squared. So there's another version of it where you have y in terms of everything else. This is one where if you knew your hk, you knew where you wanted to start the center of it, and you knew your radius, over here, excuse me, you could stick that into a graphing application or just do it by hand and come up with a bunch of points that creates this circle. Now you do have to be careful because you've got one for the positive root and one for the negative root, and you'll have to do those separately. Unless there's some fancy new technology I don't know about, which there really could be. So this is in the Cartesian coordinate system. Now you'll find circles in the polar system is a little easier in some cases. But anyway, here's the fun application of Pythagorean theorem. Let me move on to other things.